It's a core assessment video. We got the problem is citric acid, the substance that makes lemon juice sour, is composed of only carbon, hydrogen, and oxygen atoms. When 0.500 grams of citric acid was burned in oxygen, it produced 0.6871 grams of CO2 and 0.1874 grams of H2O. The molecular weight of the compound is 192 grams per mole. What is the empirical formula of the molecular formula of citric acid? Okay, the mass of carbon and hydrogen can be calculated from the masses of CO2 and H2O, respectively. The combustion analysis, the remaining mass of the citric acid sample belongs to oxygen. So we get the molar mass of CO2, we get the carbon 12 plus 16 times 2, that's the oxygen, and then we come up with 44.01 grams per mole. H2O, we get hydrogen 1.008 times 2 atoms, plus 16, the oxygen, and we get 18.02. Then we get we take the molar carbon, we get the sample over here, the CO2, and we take that and we times it by the molar mass of carbon divided by the total molar mass of CO2, and we come up with 0.2729 grams. We do the same for hydrogen. We take the grams provided of H2O, we times it by the molar mass of hydrogen times 2, and divide it by the total molar mass of H2O, and we get 0.1119 grams. Then we get oxygen. We get the total sample to begin with, and we subtract the molar masses of hydrogen and oxygen, and the difference is the molar mass of oxygen. And see, we take the grams of carbon and we divide it by the molar mass. That's the molar mass of carbon. And we get the number of moles. That's the number of moles. We do the same for hydrogen. We take the grams, the weight, the mass, and we divide it by its molar mass. And then we get the number of moles, the moles. That's the moles. Then we do the same for oxygen. We take the mass, we divide it by its molar mass, and then we get the number of moles, the molars. Now, to get the ratio, we divide by the lowest, which is carbon. We take the carbon, we divide it, and that divided by itself is 1. We take this number, the number of moles of carbon, divide it into hydrogen, and then we get the answer, the ratio right here, respectively. Same for oxygen. And now this is we got to calculate to the nearest whole number. So 1.33 is not a whole number, so that we have to times it by 6 to actually come up with the whole number. 7.995 can be rounded up to 8, and oxygen is 7.002 can be rounded down to 7. Thus, the empirical formula for citric acid is carbon 6, hydrogen 8, oxygen 7. The molar mass is the molar mass of hydrogen times carbon times the number of atoms times 6, plus the molar mass of hydrogen times the number of atoms 8, plus the molar mass of oxygen times the number of atoms 7, and the figure comes out to 192.12 grams per mole, almost identical to the approximated molar mass provided in the original problem. Thus, the molecular formula is the same as the empirical formula, C6H8O7.